So we're going to now jump to 3.6, which is called recursive formulas for sequences. So the question for today is, how do you write a recursive formula? That's a new word, recursive. We've done explicit before, and now we're going to do something called recursive. So what is a recursive formula? Well, a recursive formula is a statement that tells you the first term of the sequence, and then it tells you how the next term is calculated using that previous term. So if we look at this, it's now going to be written in as a bracket, as you can see here. So it uses a bracket, only one-sided. And the first thing it will tell you is your first term. That's what L sub 1 is. It's equal to 113. And then from there, we're going to use the previous term and add plus 41 each time. So what I should also add in here is that we're going to find the first 4 or 5 terms of the sequence. So how do we find that? The next line of this is going to be L sub n, which is just taking the previous term and adding 41. And we'll use this for integers that are bigger than or equal to 2. So for instance, if we're trying to find L sub 2, that would mean take your previous term, which is 113, and add 41 to it, and that would give you your L sub 2. So 113 plus 41 would be 154. And then we can keep doing that to get other terms. So we have our first term, now we have our second term. To get L sub 3, it would be the previous term, which again is 154 now, plus 41. And that would be 195. We'll do it 1 or 2 more times. To get L sub 4, that would mean take your previous term, 195, and add 41. You just keep doing this, right? It's 236. One more. Take 236, add 41. So that would be 246 plus 41 is 287. Whoops. So the first couple of terms of our sequence would be 113, comma, 154, comma, 195, comma, 236, and 287. Dot, 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 dot. So that's one way to write it out. So we're going to create one. Example 2 says, consider the sequence A equals 10,000, 9,600, 9,200, dot, dot, dot. The dollar amounts left on a car loan if you're paying $400 each month. Write a recursive definition for the sequence A sub n. So we're going to do a little curly bracket. So we first define our first term, which we'd say A sub 1. Our first term is identified up here, which is 10,000. And from there, we can find every other term by taking A sub n, which is going to equal the previous term. So previous term. And what are we going to do with it? Well, how do we go from one term to the next? We are just going to be paying off $400, so we're going to subtract 400. And then usually after this, they always kind of have the same kind of words, unless it changes based on like a word problem or something. We're going to add this for integers. Integers. N is greater than or equal to 2. And so that would be the definition. So you would do 10,000 to get A sub 2, take the previous term, 10,000. Now you don't have to show this normally, minus 400, and that's how we're getting the answer of 9,600. And you can continue doing this, right? This is first term, second term, third term, and so on. At the bottom of the page there, we're going to have this new notation. Instead of doing the words previous term, we'll have this new notation. Another way to write previous term is to use a subscript of n minus 1. So as an example 3, if we go back to example 1, we had this following recursive formula. So we did that a little bit ago here. What we're going to do now is we're going to rewrite the formula using the above notation for a previous term. So instead of putting the words previous term, we're going to use this notation as a subscript and show how it works. So for instance, we're going to rewrite this. It'll be L sub 1 equals 113. And now L sub n is going to be equal to the previous term, which we're going to use the subscript n minus 1. So it'll be L sub n minus 1. Now this whole thing here is a subscript, the n minus 1 part. And then plus 41. 4 integers. Whoops, n is greater than or equal to 2. Pretty important to have that, actually, because I'll make sure you use integers only. So we start at 2. I'm going to show you how this works. If we want to find the second term, you would do L sub 2. And over here, we're plugging in 2 in both spots. So it'd be L sub 2 minus 1 plus 41. Well, what is L sub 2 minus 1? That's the same thing as saying L sub 1 plus 41. And L sub 1 we know is back here, 113 plus 41, right? And that's where we got our 154, right? And you can keep doing this, right? We could do L sub 3, so it means we're putting 3 in for the ends. So it would be L sub 3 minus 1 plus 41, which 3 minus 1 is L sub 2 plus 41. And L sub 2, we'd have to go back here and look at our answer, which was 154. And you can keep doing this over and over. 195. So it does work. You're plugging in the number for the next term, and we're basically subtracting the 1 so it makes us look at the previous term each time. So from now on, we'll be using this notation instead of saying the words previous term. Now we got 2 examples left. Okay, 4. Write a recursive formula for the sequence of the first term is 2 and the next term is 4 more than the previous term. And then we'll also write out the first 5 terms. So we'll do a little curly bracket. I'll try again. This time, let's just use the letter, how about T? So T sub 1, what's our first term? It's 2. And then to get the next term, we're going to do T sub n. It's 4 more than the previous term. So I'm just going to do 4 plus the previous term, which we know is T sub n minus 1. And again, we'll write 4 integers, n is greater than or equal to 2, which means we start at the number 2 and go up. So for the first term, we put in 2. First term is 1. First term is 2. So now we're going to find the second term by plugging in the number 2. So it'd be 4 plus. And instead of doing this every single time, like you normally can do T sub 2 minus 1 and realize it's T sub 1. So it'd be 4 plus 2 to give you 6. We're just going to maybe just write what the previous term is. To get T sub 3, you do 4 plus previous term, which is 6, which gives you 10. We need the first 5, so we need 2 more. T sub 4 would be 4 plus 10, which is 14. And T sub 5 would be 4 plus 14, which is 18. And then we're going to write this out as a sequence. So we know the first term is 2. It goes 2, comma, and then all their answers we got, which was 6, 10, 14, and 18. Which obviously you could probably do this without having to write out the recursive formula, but this describes what's happening with the recursive formula rather than writing this all out in words. And then you wouldn't have to go through all this work on the left-hand side. You could probably just figure out what the sequence is. You know you're starting at 2, and you're adding 4 every single time, and that would be the sequence. And this would be your recursive definition, recursive formula. Okay, last problem for us to try. Example 5. The NCAA women's basketball tournament originally consists of 64 teams, which are paired in single elimination contests. At the end of each round of play, the number of teams proceeding to the next round is half the previous number. It's important. The sequence 64, 32, 16, 8 gives the number of teams in a tournament at the beginning of round n. Write a recursive formula for the sequence. Okay, so first what we need is our first term, which we know is going to be 64. And let's just pick a letter for this one. Let's pick B for basketball. So curly bracket, B sub 1, our first term, would be 64. Then every other term after that, we would take our previous term, and it says it's half. So one way to write that would be multiply by 1 over 2, or you could also divide by 2. So I'll try to use, I'll use a fraction instead. We'll do 1/2 times our previous number. So our previous number would be b sub n minus 1. And then same thing, we have 4 integers. Now this time, since it's a word problem, we have very specific n values. At some point, somebody's going to win the tournament, so we'd have to figure out when that is. So we'll go ahead and do that and figure out when it's going to happen before we answer the rest of this. So let's go to part B quick. How many rounds are played to declare a winner of the tournament? So we write out the terms here. We would have 64, 32, right? Everybody gets eliminated. Well, half of them get eliminated every single time. 8, keep dividing these by 2. You have 4, then 2, then 1. So how many rounds does it take? We'd have 1, 2, 3, 4, 5, 6, 7. So it would take 7 rounds. I think that's pretty much it. So it'd be for n equals 2, 3, 4, 5, 6. 7. And so we would know it would take 7 rounds to declare a winner. Okay, after that, I think all we have is team huddle and a team mastery to finish off. One thing I want to note is on this challenge problem, see how they wrote it a little differently? Instead of doing n, like over here, and then n minus 1, they actually did a little bit differently. They bumped up each one of these by 1. So they did n plus 1 and then n. But it's no different, really. So if you're going to do t sub 1 or equals 1, to get the next term, you're actually going to plug in, ironically, you're going to plug in the number 1. So you would do t sub 1 plus 1 equals t sub 1 squared plus 1. That's how you get the next term. So what we're actually finding is t sub 2, even though we originally plugged in n equals 1, right? So then you would have t sub 1, which is 1. You would square it, and you would add 1, which would be 2. To find the third term, you're plugging in n equals 2. So it'd be 2 plus 1, and then t sub 2 squared plus 1. Take the previous number, you're going to square it plus 1, so that would be 5. And you're right at the first 5 terms. So that's a little bit of a challenge problem, but it just looks a little different from what we've seen, but it's kind of the same idea. And that is actually the end of this lesson, because it's fairly short. So hopefully it's not too difficult to figure out and do. And then we'll be doing 3.7 after this one.